once made their reputation for success on the strength of fitting big science into a small space. Forecasting weather, communicating using experimental methods, and trying out new power systems are just a few of the contributions CubeSats are making to space science. Experimental CubeSats are proving their value to researchers by riding piggyback into space. NASA's InSight mission to Mars will carry CubeSats as communications escorts when it lifts off early in 2016. Now, CubeSats will get their own lift into space, complete with orbits tailored to their research and specifications up to NASA standards. Starting as soon as 2017, 3 companies will begin launching clusters of CubeSats into orbit. With new launch capabilities for small spacecraft, the science return of research off the Earth for the Earth is expected to only get bigger. Hello everyone, this is our briefing to introduce the winners of NASA's Venture Class Launch Services contract competition. VCLS is the start of having a privately developed, dedicated launch capability for NASA-sponsored CubeSats and the growing small satellite market. We'll begin by hearing from representatives from NASA's Launch Services Program at Kennedy and from the Earth Science Division at NASA headquarters, and then from representatives from the 3 companies awarded the launch services contract: Firefly Space Systems, Rocket Lab USA, and Virgin Galactic. And we'll begin first with Garrett Scrobat, the Alana mission lead for the Launch Services Program and mission manager from the Kennedy Space Center. Garrett?
Thank you, George. Good afternoon, everyone, and welcome to today's announcement of the Venture Class Launch Service. This is very exciting for me, and I can speak for the whole CubeSat community today, as the initial development of the first CubeSat was back in the late 90s, and it was at Stanford University. Today, until today, CubeSats have basically depended on other launch vehicles to obtain their rides into space as piggybacks, hitchhikers. Basically, we've been called coach class to space. And now that we have 1Us and 6U frames, just wanted to give a quick demonstration here. When we talk about CubeSats and what it really is, this is an actual 1U frame. This was in the very beginning. And the very genesis of this was a Beanie Baby box. If people can remember back in the day when the Baby Beanies came to market, they were in little glass boxes. Mr. Bob Twiggs at Stanford University said he took this to his classroom. He says, who in this class can make this a satellite to do useful science on space? And today we see where the revolution has gone to. And from there, it's grown to a 2U. And now we don't have a 3 with us, but if you take that and stack it on top, we have a 3U system. Previously in the video, we heard that InSight will be carrying 2 6U spacecraft. And this right here is the frame that these spacecraft will be going to Mars and doing a Martian flyby as InSight descends into the Martian atmosphere to collect data real time and transmit that back to Earth for the first time. So we're very excited about that launch in March 4th of 2016. So by flying piggyback or as secondaries basically meant that we had to go where the primary went. We were not able to select our orbits. We had to build our science around those particular orbits or sacrifice some of the science. However, today, now with the new Venture Class launch systems, this is no longer the case. The CubeSats will now be the primary payloads on these vehicles. We can basically say now we are riding first class. So with these opportunities, they will be able to go to their desired orbits to do their science, their technologies as they need to better enhance future missions. So within the Launch Services Program, we manage the Alana educational launch of nanosatellite missions. And to date, we have launched 10 missions. Last Thursday was our 10th flight, of which 41 CubeSats have flown. So of these 41 CubeSat missions, 20 different universities across America have been represented flying their CubeSats. We select our CubeSats through the agency's CubeSat Launch Initiative. This is the approach by which we put a call out every year, and right now we're in the middle of the call to accept proposals from educational institutions, nonprofits, or even NASA centers will send in proposals. We evaluate the proposals, we put them on a priority list, we submit them, they hand them over to us, and we start manifesting as we go down the pike. With that, over the next 13 months, we still have 5 more Lana missions to fly with 14 CubeSats. And now, over the next 3 years, with the big help from the Venture-class launch systems, we will be able to fly our 50 unmanifested CubeSats on our CSI priority list. So one announcement I can make today, George, is that we can now name our missions Alana 19, 20, and 21. And each one of these missions will carry anywhere to 45 to 90 1U equivalents on these missions. So back to you, George.
Thank you, Garrett. And now to Eric Ianson, the Associate Director for Flight Programs for the Earth Sciences Division in the NASA Science Mission Directorate at NASA headquarters. Eric?
Thank you, George. It's very exciting to be here today for the announcement of the awardees for the Venture Class Launch Services. Most of the panelists here are from the launch vehicle side. I'm here to represent one of the organizations that hopes to utilize this new capability. NASA's Earth Science Division pushes the envelope for remote sensing instruments and missions. Venture Class investigations are designed to develop and innovate small science-driven payloads. Through the Venture Class program, NASA's Earth Science Division solicits instruments where NASA finds the spacecraft and the ride, as well as complete missions. A low-cost launch vehicle capability to support small, low-cost, innovative payloads is a key step forward for Earth Venture projects. Developing low-cost launch vehicles that provide access to space for these payloads will result in a sweet balance between mission capability and investment. Affordable launch vehicles will allow NASA to fly complete yet low-cost missions that remain focused on science data. The key from an Earth science perspective is getting science payloads into space when and where they are needed. That is, we don't have to compromise science objectives to conform to the mission needs of a larger primary payload. The Earth Science Division's support for these emerging launch vehicles is clearly demonstrated by our participation in this exciting activity that we're discussing today. I congratulate the awardees and look forward to these launches as a key first step for the future. Low-cost launch vehicles like these will allow us to add CubeSats today and even larger small satellites tomorrow to our science toolbox. Thank you. Back to you, George.
Thank you, Eric. And now to Mark Weiss, the Flight Projects Office Chief for the NASA Launch Services Program here at Kennedy Space Center. Mark?
Thank you, George. So again, first off, a big congratulations to the awardees. This has been a big push that we've been going towards, and to get here today, it's a huge step for the commercialization of space, even though we're talking about 3 smaller rockets. So Launch Services Program, which we represent here at Kennedy, we are Earth's bridge to space. So we provide the science community that Eric's here representing, from exploration to earth science to our galaxy, that way to get up to space. So we've been here for the last 15 plus years at Kennedy, leveraging project management, integration, engineering, and analysis skills to try to make that hard rocket science business easy. Whether it's a New Horizons mission that we just saw going to Pluto, or a Mars rover exploring, to the amazing earth science stuff that helps us understand our planet today. So we serve the science community as that launch broker. So the goal of helping enable a healthy U.S. commercial launch industry. And we're always seeking ways to lower that cost to try to help more science get to orbit. So the Venture Class Launch Service was born out of a strategic initiative led by Launch Services Program, rooted in that drive to seek a new way to get to space, with a lower price tag compared to that 100 million plus that we see traditionally today for the larger missions. Today, the world's at a unique pivot point with the launch market. So we have a chance to enable this new commercialization of space growth that CubeSats have opened up. So there's both new and veteran companies that are pressing ahead with big plans for using space as a platform to improve our everyday lives. The Kennedy Space Center here has been pushing to improve and become a multi-user spaceport for all kinds of launches going forward. And we're at a point in technology where innovations, manufacturing, and the growing need for data in our hands real time has kind of opened the door for where we're at with CubeSats. So space is no longer just for high-value science or the intelligence community. It is a place for a payload that you can create that can get up to space. So our strategic step here with VCLS is to enable that future class of rockets for CubeSats and the small sat community as it grows. And we're here today from that amazing investment in the Earth Science Division and helping us try to bring this capability to market. The healthy competition that we're able to spur forward with these 3 awards will help us all stay on the leading edge of making sure this industry thrives. These 3 vehicles that we're going to provide to you today and show you, they're all commercially developed. So traditionally, when the government brings a new capability forward, it's something that the government puts money out to try to develop. Here, because of that emerging commercial capability, the emerging market, there's private investment backing the non-reoccurring development costs of these rockets. Traditionally, that represents 10 to 20 times an initial upfront cost of what you see for what we pay for a launch service. The government doesn't have to foot that bill today. So we are able to bring forward a new capability with the success of these launches. So we've bought 3 demonstration flights. These 3 companies will, before April of 2018, will demonstrate their launch. It'll give the Launch Service Program insight and help open the door for the science community to bring new, smaller payloads forward. We're excited for the competition. I can only begin to imagine the opportunities that these companies will open up for you, your children, and the world. George, thank you.
Thank you, Mark. And now to the representatives from the awarded launch service providers. We'll begin first with Maureen Gannon, the Vice President for Business Development for Firefly Space Systems. Maureen?
Great. Thank you, George. Good afternoon. Hi, everyone. Before I jump in and talk specifically about Firefly Space Systems, I'd like to take a moment to thank NASA for making this possible, this event, and for the Venture Class Launch Services in general. So thank you to the VCLS team. On behalf of myself, I am honored to be here today to accept the award of a Venture Class Launch Services contract on behalf of Firefly Space Systems. We see at Firefly Space Systems VCLS as a vital step in the much larger mission of growing not only Firefly Space Systems, but the small launch industry as a whole. So let me talk a little bit now specifically around Firefly. So Firefly was started in just January of 2014. And since day one, our mission has been to dramatically reduce the cost of commercial launch for small satellites and science missions in the sub-1 metric ton payload category. And since I've had the honor of being also part of Firefly since day one, I've been able to watch it grow from a company of 4 people into the enterprise that it has become today. And I have a video here with me we can roll to take a look at that.
January 2014, and the birth of Firefly Space Systems. Our mission, to change the game for access to low Earth orbit. In just 20 months, Firefly has completed key design reviews for our Alpha launch vehicle and built many of the key components, such as avionics and composite tanks. We have designed and manufactured engines and built our 20,000 square foot R&D facility. We have completed our first test stand on our 200-acre test site and hot-fired our engine. Firefly will launch NASA spacecraft to low Earth orbit in March of 2018. Getting things done. Firefly.
Great. What I'd like to add to that is behind everything that you saw there, every milestone, every component is a human being, a part of our team, which is the most valuable asset of Firefly Space Systems. And without them, we wouldn't be here today. For the last 20 months, they have worked tirelessly on developing our first vehicle, the Alpha, which is a 2-stage, all-composite rocket capable of delivering up to 400 kilos to LEO. And we think it'll be unlike anything that's come before it. We're very excited about it. So that's where we are at now and looking forward into the future, in 2017 we will start our series of test suborbital flights from right here at Kennedy Space Center under an agreement we have recently inked with Space Florida. We're very, very excited about that as well. So at that time we'll be proud to call ourselves Floridians and signal to the world that the most exciting and innovative technologies in space access are still happening right here on the Space Coast. Then in 2018, our company will begin launching orbital missions, eventually ramping up to 50 missions per year. So that means we will be offering weekly scheduled access to LEO and allowing customers, such as NASA, to pick and choose the flights that work best for them, that fit their mission and their schedules, so they no longer have to fly coach. So with that said, we're greatly encouraged knowing that NASA shares our industry's vision in low-cost boosters to enable even more exciting and less expensive missions in exploration, science, and education. So NASA's vote of confidence in our team and our technology is a significant boost to our efforts and our goals at Firefly of making space for everyone. Thanks very much. George?
Thank you, Maureen. And now to Peter Beck, the Chief Executive Officer of Rocket Lab USA. Peter?
Thank you, George. So this is a very exciting time in space right now. In the last few years, what we've seen is small satellites decrease in mass on average by about 75%. So the missions that were typically done by a satellite the size of a car are now done by satellites the size of a refrigerator or even smaller. But of course, what's required to enable these missions is a small dedicated launch vehicle. And what you see here is not one, but 3 commercial companies all striving to provide that service. And NASA in turn are enabling that service by this venture class program. It's testament to NASA's vision for the future to invest in something this early, and it's truly fantastic. Now, Rocket Lab USA is pretty far along with our Electron launch vehicle. Our first test flight is scheduled for early next year. And we'll be flying our NASA mission on Flight 5, which is late 2016, early 2017. Electron lifts around about 150 kilograms to a 500 kilometer sun-synchronous circular orbit, or a few hundred kilograms to a low Earth elliptical orbit. Now, cost is only half of the problem here. The other half, of course, is being able to fly frequently and be able to fly on schedule. And Rocket Lab has gone to extreme efforts to ensure that is a reality. In fact, we've gone to other countries to build launch sites to enable that, and to enable our customers to choose from just about any inclination they need, and to be able to meet the schedule they need and truly be able to fly weekly. Now, you've probably seen a lot of hardware from Rocket Lab over the last couple of years, but we really thought it was time that you saw some of the team behind Rocket Lab who make this happen. So if you can roll that video, that would be great. Thanks. Throughout history, people have created a lot of things, but now and again something is created that in itself is great, but what it enables is truly extraordinary. At Rocket Lab, for the last 8 years, we've been known for the innovative technology that we create. But whichever piece of technology that you look at that was created here, there was always a Rocket Lab person behind it. We thought it was about time that you got to know the team who are dedicated to making it happen. The people who dream it, who design it, who build it, test it, and who fly it. So this is us. And then there's you, using space to provide technologies to improve life on our planet and beyond. You've met the team here at Rocket Lab building Electron. Now it's your turn to use it to do something extraordinary. So, What Rocket Lab is about is enabling small satellites to do really important things that affect us all. And we're just so excited and honoured, really, to be able to fly these NASA missions and see what extraordinary things in science and innovations NASA is going to do with this launch vehicle. So, you know, we're just so excited to be able to give a first-class ride first. Thank you.
Thank you, Peter. And our next winner is Steve Isakowitz, the president of Virgin Galactic. Steve?
Thank you, George, and thank you, NASA. My hat goes off to those people at NASA because I know any time to start a new program in Washington is a challenge these days, and really appreciate the effort that's gone in for this new innovative program that's not only going to unleash the revolution that's going to be created by small sats, but also is going to change the way on how we conduct business and how we work with NASA. So thank you for that. At Virgin Galactic, our mission is driven by democratizing space. And in short, we're trying to open up the space frontier to all. So we've done it in two forms. One is our spaceship effort, where to date, 551 people have had the opportunity to go to space, many of them here at the Kennedy Space Center. And at Virgin Galactic, we hope to exceed that number with the kind of people that want to also have the opportunity to experience space. NASA has also contributed to our efforts. One of the things we try to achieve in the spaceship program is to provide experiments for people who used to fly in the space shuttle to have the opportunity to fly their experiments in a suborbital environment. And NASA created the Flight Opportunities Program to enable that. Now, our second product is the Launcher One effort. And there again, NASA has come through with this venture-class launch system, which is a great opportunity to facilitate what the private sector is investing its own money in. The revolution in small sats is extremely exciting. Just last week, I had a chance to visit a university and meet with some of the undergrads that were having an opportunity to work on Cubesat class satellites. What was particularly exciting is they were doing it not just as an academic exercise, they were doing it with the thought that before they graduate, they'd have the opportunity to see it fly. Moreover, during the same visit, I had a chance to meet with some of the students that had recently graduated from that place, and they were starting up their own small sat companies with new technologies to change how these small satellites are built, as well as new applications on how they are used. Now, in the private sector, we're now seeing that this is not just the playground of people who are interested in the technology, but this is real business. We find ourselves with private, institutional, and venture class investors that are putting serious money to see that this happens. We are super thrilled that NASA has now joined this. Our initial flights have already been booked as we signed a major contract just a couple months ago announced to fly commercial communication satellites in the small sat class. That has provided us an important start on our efforts. Now NASA is joining our manifest. Before I go to the video, I just want to highlight a few of the words that we're going to put in our video that I don't want to make sure they don't go by you too fast. As you've heard today, dedicated is extremely important to enabling this class of payloads. We have gone too long with small payloads having to be secondary and having to wait for when they have the opportunity to fly or getting to the orbit they want to go to. So when and where is extremely important. Responsive. This is looking through the eyes of the customer and something we take very serious. What are the impediments that would enable this emerging field of small satellites? And it's the ability to go to the orbit that you want to go to from multiple locations. So this is where we, through our innovative air launch design, have come up with an approach that gives you exactly the kind of flexibility that allows you to go anywhere where you want to go, when you want to go. We are fully funded, which means we have made the investment commitment to take us through our development program and into our test program so we can begin operations. With this, we've used it as an opportunity to really think through from the get-go what a good clean sheet design is to make sure you can build an affordable, fast, and flexible launch system. Second, we've made a major investment in our people. Today we have 150 people, and we are still growing, adding people to the ranks who bring a fantastic experience base. In fact, if you look at our current team, our team has worked on just about every U.S. launch system that is flying today. Moreover, we have also hired people from outside the industry to bring new ideas on how we can do things better and faster. We've also made a major investment in our facilities. We just moved into a brand new facility a few months ago in Long Beach in Los Angeles, 150,000 square foot facility where we're starting to outfit it with state-of-the-art machining and tools to allow us to do some 3D and other advanced manufacturing. Lastly, we are achieving some very impressive results. Too numerous to go through here, but just last week we had the opportunity to fire our first stage engine for 90 seconds, and it provided us just the results that we expected to see at this point in time, and kudos to the team to help bring that together. So with that, let's roll the video. Thank you, George. Back to you.
Thank you, Steve. And we're ready now to take questions. We'll begin first with news media here in the room. Then we'll go to the telephones for media off-site asking questions. And then we'll take social media questions, which you can participate in by going to #AskNASA. So we'll start first here at Kennedy Space Center. James?
Thanks, George. James Dane, Florida today. So, of course, I'm interested in the potential for launches from here at KSC. Thank you, Maureen, for stepping up to start it off there. But could you clarify, you mentioned an agreement with Space Florida. Does that mean, would you be using 39C or a different site for your launch? And will that include your NASA launches? Is it just the suborbital test flights you mentioned that you're starting with?
Well, for now, I can say that it will be our suborbital test flights, and we are aiming for 39C.
And for the other guys, I understand you can do this from different places, but are you committing at all? Do you expect to launch your vehicles from the Space Coast, or, Mark, I don't know if the missions will necessitate different launch sites along the way, how that's going to work? Thanks.
So the requirement we put out for them was that they could launch from anywhere. There was no specific bias where or other, but we're letting that be up to them. We gave them a range of inclinations they could launch from, which opens up Kennedy. It opens up other options. So I'll let them speak for themselves.
So from a Rocket Lab perspective, we have signed a NASA Space Launch Act agreement, and we are in discussions with the KPF for the use of 39C. 39C just gives us that nice little sweet spot of inclination that we can't get out of some of the other sites that we have. So we're definitely pursuing it.
For Virgin and Galactic, of course, we have flexibility given that we are air-launched. Our plans is to start the program for ourselves. We're going to be flying out of Mojave, out in California, but we do have the ability to use the shuttle landing site for our own flights out of the Cape.
All right, any other questions here in the room?
You mentioned this is a competition. Daryl Nail, Fox 35 in Orlando. You mentioned this is a competition. Is there a second round to this, and does that come with a level of funding, and do you narrow down the field that we see here?
So the way we set it up was to go out and buy a commercial launch service. So it was simply one round we've got milestones in our contract that help us walk these providers through the design process, a test program, and then the final launch integration. So we don't have an option in there to go buy additional flights, but by allowing them to compete in this demonstration flight phase, it kind of opens the door for us to look at their maturity and then have them out there as an available option for the science community as they grow into potentially looking at using this class of launch services.
And for the Firefly, what kind of launch can we expect to see from the Space Coast here? What will it look like?
Well, hopefully spectacular. So it will be the test flights that we will launch from here will happen in 2017. And I guess, what do you mean by what will it look like?
In terms of, a lot of launch watchers like to observe launches out here. There's different characteristics of the different vehicles. Yours is smaller, so will there be the rumble, the boom, the light?
There'll be rumble, there'll be boom, and it'll definitely be worth standing and looking up to the sky and watching it go. It's going to be amazing, yes.
Any other questions here in the room? All right, let's go to the phones. First, we have on the line Jeff Faust from Space News.
Hi, thanks for doing the press conference. I want to ask for the NASA representatives here if you can explain what criteria you use to select these launch providers, given that nobody so far has actually done any launches. What were you looking at to choose these, and from how many proposals did you select these 3 providers from?
Hey, Jeff, this is Mark. Appreciate the question. So as our traditional acquisition process goes, we unfortunately can't give you how many bid on the contract and how many were there, but I'll definitely let you know there's a field out there that's trying to be the first to bring a product to market. So we're excited that we're able to award 3. I mean, it's an outstanding opportunity for us to really get that first push for competition. From an evaluation standpoint, so we had a balance of cost and their capabilities. From the capability side, we looked at the plans they have in place. We asked the providers all to give us a systems requirements review level package so we could understand how mature they were in their development. And then we kind of looked at that and balanced it with the cost to make sure we had the best viable solution going forward so we could see this as a successful venture.
All right, Stephen Clark from Spaceflight Now.
Hi, thanks, George. Stephen Clark from Spaceflight Now. Just a couple of questions. First, maybe for Mark, from the Launch Services Program perspective, going forward, are you involved in your normal process, readiness reviews, technical reviews, going up to flight certification, or are you just along for the ride since these are considered low or high risk type payloads? And also for Virgin Galactic, you recently announced you're enlarging your Launcher 1 vehicle to carry up more payload to orbit. Have you selected a new carrier aircraft for that vehicle? And what is that? Thanks.
So appreciate the question. Again, you got it right. We're definitely going after a high-risk approach here. So the CubeSats represent that high-risk tolerant payload, which are perfect for a demonstration of a first flight. So from the Launch Service Program's perspective, again, we're along for the ride with our low-risk tolerant, high-value spacecraft. This time we're trying to step back a little bit and make sure the government gets out of the way, doesn't inhibit the commercial solutions these companies are trying to bring forward. But we're going to definitely get insight so that when we do go forward and try to procure a launch service for a low-risk tolerant spacecraft, we're one step ahead of the game with trying to certify them to make sure they can get a safe access to space.
Steve?
Thank you. Yeah, as to your question about increasing the size of our Launcher 1, from the get-go we had a design philosophy that looked to have a launch vehicle that was evolvable. And as we continued to study the market, we knew we were ready to respond to what our customers needed. And it was pretty clear to us that our customers were looking at launch vehicles in the small sat range that would be above some of the capability we were going to have in our original design. Fortunately, we had the kind of design through the engines that we were building that without actually making any changes to the engines themselves, but just by stretching the vehicle, we were able to get a vehicle that essentially could double its performance for about the same price point. And that's pretty exciting to our customers. As a result, we are going to be flying on a commercial aircraft, and we do expect in the coming short while here to announce exactly what aircraft we'll be flying on.
Our next, Steve, did you have a follow-up? Okay. Randy Shostak from EOS. Randy?
Yes, hello, can you hear me?
Yes, loud and clear.
Yes, thanks very much for doing this. Couple of questions. First of all, can you clarify what will be the key milestones that you'll be tracking with these launch vehicles?
So what we've set up in the contract is we will follow these providers through their preliminary design, critical design. We have a qualification test milestone where we can ask them to showcase their major technologies, and then we'll look at that data, review the qual test data, and then work through our typical launch campaign type milestones.
To the company representatives, please. How do each of you view the other selected companies?
Who wants to go first?
Well, I mean, I'll just say, we're very excited. I'm a true believer in competition and the competition of new ideas, and I think that's what's so great about this segment of the market, whether it's the satellite companies that are building these new small sats and cubesats or the launch providers. You're seeing companies that are coming out to solve problems in very different ways, and I think that's healthy. Personally, I actually applaud it every time I see a launch with these small sats being deployed. Sometimes I'm asked, do we view them as competition? And I actually just view that as great opportunities to see the market grow, because I think as these satellites get demonstrated in orbit, I think the demand will grow for them.
Yeah, and I totally agree. I mean, a bit of healthy competition is great, but there is also rocket karma, and you never put down any other rocket company because it is a really hard thing to do. So competition's great, and we look forward to competing.
And I would echo the same. I think the competition is fantastic, and with the growth that we're seeing in the market, I think you're going to see a lot of different companies that are going to be competing for this space as well, and the market will continue to grow, and we'll see more competition.
Thank you.
Our next questioner is Caleb Henry from Via Satellite Magazine. Caleb?
Hi. My question is just how many launches does NASA anticipate needing, I guess, once this program is up and running? And then a quick follow-up would be, do you anticipate certifying other launch providers in the future?
So maybe I'll start. Again, we bought 3 demonstration flights. Once it gets up and running, again, looking towards their success and looking towards the future, it's the science community that drives that requirement. So I'll let Eric kind of maybe give his take from the Earth Science Division standpoint.
Well, from an Earth Science standpoint, we look to we have a very regular cadence of competed missions that we put out there. We look for instruments, and we look for complete missions. So our instrument solicitations go out every 18 months. Our full missions go out every 2 years. So from that standpoint, we let the science drive what it is that we're looking for. So we're not necessarily looking to fly CubeSats per se, but we're looking to fly specific science. Now, when a CubeSat or a small sat can do that science, that's great. That's what we're looking for. So I think there will be plenty of opportunities within the Earth Science Division alone to fly on this type of launch vehicle into the future.
All right, we'll take some social media questions now from #AskNASA. So could we have our first question?
Right. This one's aimed at the whole panel, really, commercial companies specifically. Can these small sats only be used for scientific research, or could they be used for commercial use such as TV, radio, and Internet?
Well, I mean, I can speak from Rocket Lab's perspective. Our manifest is looking pretty full right through to mid-18, and the majority of those missions, in fact, the vast majority, are all commercial customers. So these are customers doing Earth observations and communications. So, most definitely the commercial small satellite guys are leading the way here.
Yeah, I would agree with that. We see the demand coming in communications. With our customer at OneWeb, they're putting up a large constellation of small satellites. We're seeing a lot in Earth observation. And we're looking at companies doing some pretty innovative things that are different outside the norm. So we do see it very much as an expanding market, and some things we're not even thinking of. Some of the stuff I've seen that NASA is doing right now, like sending a couple of CubeSats off to Mars, who would have thought it just a short while back. It's all been enabled by technology just in the last few years that's made this all possible.
And I would echo that as well. The majority of the customers that we are talking to, mostly commercial, are wanting to do polar Earth observation, but there's not a day that doesn't go by when I don't get a phone call from a company that I'd not heard of before, looking to do something that absolutely boggles my mind. So there are really interesting developments happening every day.
Another social media question?
This one says, when will rocket ships and other spacecraft like these are vehicles, be able to take public to space?
Well, we're already doing it. So you could tell whoever asked the question that just signed up for a spaceship ride, and we're happy to take them on a wonderful opportunity to see space.
And we have a fundamental policy at Rocket Lab not to fly meat, so we'll just leave that to Virgin.
I think we've got, just by flying these CubeSats, we're letting the public get into space. I have a 11-year-old home that's working on a science project, and the thought that in only a couple years, and there's some classrooms able to do it today, where these kids are going to be able to do science experiments from a satellite in space versus messing up the kitchen at home. So, the opportunity is already there.
Any other questions on the social media?
Is that one more?
Yes.
Can we talk about the differences between capabilities and the new venture class systems compared to rideshare as done before?
You want to take that one?
In the beginning, we do the ride shares, and it depends on how much excess capacity is left on the launch vehicle for us to go use. A lot of times when a NASA mission is going to a particular orbit, they want to use as much performance of the vehicle they can to ensure they get the maximum amount of science out of it. Now, if there is an extra 50 kilograms on the vehicle, we put as many CubeSats as possible on there. On the Delta II, right now we put 3U payloads, about 12 kilograms worth of actual science payloads on those vehicles to go fly. Now, when we're switching over to the venture class, we have the opportunity to do at least a minimum of 60 like our requirement is, but even more. So we're looking at, instead of doing 3Us, we're looking at 15 to 33s on a particular mission.
All right, let's do one more check here in the room. Any further questions? Daryl.
The NASA mentioned that flight is expensive, $100 million for regular launch. Do any of the company representatives have any estimates on what it will cost, being that this is now going to give access to everyone virtually? What will it cost to get into space?
You mean for the entire vehicle? Okay, so for us, for an entire vehicle, it's $8 million.
And for Rocket Lab, our beginning price is 4.9.
And for Virgin Galactic, we have advertised it as being under $10 million.
And follow up to NASA, with greater access and all these CubeSats flying into space, is there a saturation point? Do these things ever come down?
Yeah, they do come down. We have guidance, NASA policy, orbital debris that we have to follow, and we follow to the strict point of the law. One of the things about these particular missions is that we're only going to like 425, 450, which allows the CubeSats to do about 2 years worth of science on orbit and then re-enter to the atmosphere and be out of the way of other spacecraft.
So is there a saturation point?
I don't think we're there yet.
No.
Can there be one?
Down the road, and it's something I think that everybody's looking at is obviously a sensitivity at times, but I don't think we're there yet. And with the orbital debris policies in place that the government is strictly following, I think it's not something that we're all jumping around worried about.
James.
Thanks, James Dean, Florida today, and maybe for Mark again, in terms of the competitive aspect here. You've selected these companies. Is there any further competition remaining about who flies first or who gets to fly which payloads, or are they all interchangeable on each vehicle, or is it already set who's flying what and when?
We haven't manifested certain payloads onto certain vehicles yet, so there is competition inherent kind of in the process. We don't want them all to rush. We gave them that requirement to launch by April 2018, and we want them to drive that schedule based on their own cadence. I know Garrett's suite of payloads will be matched to the specific orbits that the vehicles will go to, but no specific follow-on that we have set in the schedule right as of now.
For any of the company representatives, could you just touch any further on how important, helpful, necessary this type of commitment from NASA is? You're all referencing other flights that you have manifested. So, if there is a growing market, you're already tapping it. Did you need NASA to step up to help you sort of make the business case for other flights, or is it just a matter of trying to show NASA that you can carry perhaps more valuable payloads down the line, or just kind of what does this program mean to you?
I can jump in, and as I said in my comments earlier, I feel like this is a very vital step for us in growing this market in the larger realm. So we feel that, like the commercial customers, NASA is a very important customer to us, and knowing that they support the industry helps us greatly. So yes, it's very important to us.
Yeah, and like Virgin for Rocket Lab, we're fully funded as well. But having that NASA stamp of approval and that science that can be done, I think is hugely important for the government aspect to endorse these small launch vehicles.
Yeah, and as for Virgin Galactic, I think it is important to see that the government is participating, and participating in a way that sort of reflects the class of payloads that are being flown. Sometimes you can turn an inexpensive launch vehicle into a very expensive one if you levy too many requirements on it. I think NASA's taken about the right touch on this. I'm looking to get these payloads access to space while for the best price and for the best value available. I'd also add that it's nice working with NASA. NASA brings a tremendous amount of technical expertise. The Launch Services Program has a fantastic record of success. So I think working with NASA will also help just improving the quality of the launches and the services that we provide.
And we got a follow-up on the phone from Stephen Clark from spaceflightnow.com. Stephen?
Thanks again, George. Just one clarification. Matching the prices that were quoted by the industry representatives and the contract values, they're not exactly the same. I wanted just to clarify maybe the reason for that, and is there a possibility that other payloads, non-NASA payloads, could be manifested on these NASA demo flights, or is this NASA purchasing the entire launch in these 3 demo flight cases? Thanks.
So I'll start. So this is NASA purchasing the entire launch. So we put out a requirement for 60 kilograms to low Earth orbit, but we do own the full capability of those rockets. So anything that we can squeeze out of their capability, we will. And then I'll let them answer on the price, but from our perspective, again, we are buying a demonstration mission, so we know we're one of the first flights of these companies. So obviously more risk on a first flight, so there's potentially a discount there, a chance for us to get in early as an early customer, but they ultimately will drive the price based on the commercial market that they're looking to serve.
In the case of Virgin Galactic, our price is relative to the level of risk the customer is willing to undertake. In the case of NASA, they wanted to fly on one of our early launches, which we plan to start off with our test flights. As to what prices will be for follow-on activities, reflects what the customers want on specific launches.
And from a Rocket Lab perspective, NASA will be flying on quite late flights for us. We'll be fully commercial by the time we fly the NASA payloads, and our price is a little bit higher, based on the extra requirements are involved for the NASA mission over a standard basic commercial mission.
And for Firefly, NASA will be flying on some of our earlier missions, so there is some risk in there, and we did take that into consideration in the pricing.
Let's do one more sweep of the room for any further questions for the media here. All right, well, in that event, that will conclude our briefing, and thank you very much.